Welcome back to Innovation World Young Collaborator podcast series. Today's podcast is titled, Let's Start a Farm on Mars. My name is Sid. This is the person who's going to be interviewing another person. I am 9 years old and I live in Carlisle, Massachusetts, USA. Today's guest comes to us from Columbus, Ohio, USA. You may know of that place. I first learned of his work during my very first global innovation field trip and was totally fascinated. Here is the one and only Jim Bruner.
Thank you, Sid. That was lovely.
Can you tell us more about your Mars farm idea?
Sure. So Project Martian is how I designed a bioreactor. So it's important that you know what the bioreactor is supposed to do. What happens in my vision is we take all the leaves that fall, all the brown leaves, and we put them in freeze-dried packages that are vacuum sealed, so they don't take up a lot of space. We take all the grass clippings that we can, every bit of grass and green leaves that we can, and we put them in a freeze dryer and package them so we can ship 100 times as much leaves and grass as we could if we did it as bulk, right? And the bioreactor itself was designed to take advantage of the fact that IBCs, intermediate beverage containers, which are those 1,000-liter cubes that are surrounded by a steel cage, are almost indestructible, and they're light. And so the vision for the bioreactor was that we would ship this with all the robots, all the technology, all the shielding, and all of these freeze-dried browns and greens for compost, along with systems that could synthesize from the Martian atmosphere ammonia, glucose, and ethanol, or ethyl alcohol. And that robots would stack these into towers, and you could have 20 of them. And while we're getting ready to send people to Mars, the robots could be loading in compost, allowing the water that's collected from the sun and from the wind turbines, because Mars is very windy, and turning that power to create compost. And when that compost forms, the robot pulls it out, puts another one in, and then treats it with dirt and Martian regolith so you can grow food in it. And by the time that the Martian settlers were there, there could be a huge pressurized dome filled with breathable atmosphere and lots and lots and lots of food growing that was produced literally as a partnership between the Earth and Mars, robots and the sun, which still produces energy as far away as Mars is, and the winds on Mars are 100 times more powerful than they are on Earth. So turbines are a no-brainer. And that was the vision. That's what the bioreactor was. And that's why I called it Project Martian, because it was my solution to how we're going to feed people and make water for people who are going to be living on Mars eventually. You don't have to do it all in one day. Do it over 2 years while you're shipping people from the planet to Mars. These robots should be making growing environments. So people arrive on the planet with food ready to go and systems that are ready to make more food on demand. That's it. That was Project Martian.
So could you explain a bit more on how you're planning to get water from Mars? Because all of your Mars talk just reminded me of one of my old projects about getting water from Mars, and I was wondering how you're going to get water. I might have missed it, but could you explain a bit more about that?
But you don't understand the relationship. All the water on Mars is going to come from Mars. I told you in the bioreactor this year, or not the the biodome, we will be using solar power and electrolysis to separate out hydrogen and oxygen. Well, that's what we'll do on Mars. We will pull oxygen from the atmosphere, we'll separate it from the CO2, which is the large majority of the atmosphere on Mars is CO2. We'll lock carbon into the compost, and that leaves us free oxygen. We'll pull the hydrogen out of the Martian regolith. We'll combine those two things together again and again and again and again in a system that creates hydrogen and 2 oxygens, boom, water. we have the energy, we have all the technology, we will literally be manufacturing water from the environment, just like I'm doing here in the biodome this summer. That's how the system was designed to build water. It would just synthesize it from the planet itself. It's not hard. It's expensive because it takes a lot of energy. But turn that wind power into energy. Use your technology, use your understanding of electricity and put pressure or current behind it, and you can make a lot of water and oxygen, and you can fill that dome with breathable atmosphere and fill those cisterns underneath that dome with millions of cubic liters of water. Done. That's how I plan on doing it.
Okay. That's an interesting explanation. Did you know that there was some research a few years ago about something about Mars having polar ice caps? Have you considered that as a variable to this?
Certainly, I have. But the problem with that is the same problem we're going to have here in the world today. In places that are normally frozen, there is a substructure of ice underneath the ground that's called Arctic melt. It has another word. It is it's a desert called tundra, and when you take that ice out, the soil collapses and it becomes unstable. We don't know what that water is doing on Mars, and it's in a very inhospitable location. There is water in the soil of Mars, but it's frozen into the soil because it's so cold there. We don't know enough about that. And if we were to dig that out and there was a very harmful pathogen that just happened to be able to survive there, I think we should do more research about that before we start pulling water out of the Martian regolith, not knowing what the side effects will be. It's called the law of unintended consequences. I think it makes much more sense to mine the water from the atmosphere where you can do as little damage as possible than to go into an ecosystem that you know nothing about and just start pulling resources out with no knowledge of what you're doing or what its impact is going to be. Do you agree?
I would agree completely. That means I have to change my idea. Oh, completely. But we'll see what I can do about that.
That's what the water is called, permafrost. It's frozen in the soil and it's melting now, Sid. It's melting now, and there are pathogens in that permafrost in the Arctic tundra and in the Siberian tundra. We don't know what the impact that's going to be. I do not suggest going to Mars and making the same mistake.
I would agree completely. So, next.
Any other
What?
Any other questions?
Yes, I have a few more. So
Okay.
I really like the Martian movie. If you have watched that, you might know what I'm saying. Have you watched it?
I've watched it multiple times. I own it. I've read the book multiple times. I loved Artemis. I love that author. Yes, that is one of the reasons I built the bioreactor, is because of Andy Weir and The Martian.
Okay. That gets to say that you like it too. So I always wondered how accurate the depiction of the science and everything about Mars farming. Like, since you are kind of an expert in the topic, could you give us your opinion on if that actually could work later in the future?
I don't think it could, because Project Martian, its first iteration was a failure. It grew food the first year, but the pathogens that grew in that compost were more aggressive than I had factored in, and so I had to stop those and stop that process and bring the nutrient levels of that compost back up to a sustainable level. So you literally need dirt. You need mineral dirt. The regolith is too fine. The stand-in that I used for the Martian soil was plankton, the shells of plankton, which is called diatomaceous earth. And it's just too fine. When it breaks down, it doesn't have any oomph to it. And life needs crystal structures in the soil for roots to grow properly and for roots to take in liquid nutrients into their root structure. So he could not have survived on the planet for 2 years using only his waste and Martian regolith. That's just too much. He would have needed some other kinds of minerals to mix in there, not to mention select microbacteria and insects that are necessary for roots to grow, especially a tuberous root like potatoes. Potatoes grew the first year in the Martian compost really, really well, and they continue to, but not as well. But any kind of green vegetable, forget about it. Potatoes and sweet potatoes were the only thing I could grow in it. So it was true, you could grow potatoes, just not well.
Okay. Oh man, I really thought that was gonna work. So what? So how far? Well, actually, no, that's not the best question to ask. I read that you practice Tai Chi when you're not checking on your billions, gazillions of plants and all that kind of things, which I recently discovered that you don't do. You make robots do that all for you. Could you tell us, our audience, how that helped you and how that may be helpful to them?
Yes, it helps me in 3 ways. One, it keeps my body fit. I stay flexible. I'm able to move. And when bad things happen, like, oh, I don't know, a tower starts to fall on you, you can jump out of the way quickly. That's the first thing. The second thing is it helps me manage my fear. It helps me manage my anxiety because, building something like this, a lot can go wrong and a lot does go wrong. And I get really mad. And what good is that? So I do Tai Chi to balance my mind and my fear and my anxiety. The third thing it does for me is the reason that I learned Tai Chi is when I lost my esophagus from the surgery, I was paralyzed. And the way that my neurosurgeons helped me learn to walk again was Tai Chi, because it requires that you use both sides of your brain. You have to use the right side of your brain to imagine what you're doing, and the left side of your brain to control where you're going. So your muscles are controlled by the right side, and your reason is controlled by the left side. And it allowed my brain to rewire itself so I could use the left side of my body again. So it literally allowed me to walk. And I honor it as one of the most useful tools I have in my arsenal to keep me focused. It keeps me alive, it keeps me healthy, it keeps me reasonable and kind, because I'm being kind to myself when I do it. And I teach other people to do it because I want them to know what it is to love yourself and how to treat yourself kindly. And that's what Tai Chi does for me. I can't use it to hurt someone. I can only use it to improve my life and the life of everyone around me. It's not a weapon, it's a tool.
Okay, that is a really, it's an explanation that has as I said earlier, bad things happen, good things usually come out of it. Well, this is an example, so now you know how to keep your mind in a really good balance. So, I have a heavy heart, and I have to say that this podcast episode has ended. I know our listening audience has thoroughly enjoyed learning about all of your work. Learn more about this program and others by visiting globalinnovationfieldtrip.org and innovationworld.org. Thank you for joining the Innovation World Young Collaborator podcast series. This is Sid, signing off until next time.